Good afternoon, all of you. Today we'll be starting with module number 3, electrochemical machining. Electrochemical machining is an unconventional machining process that is used for the machining of electrically conductive materials only. Listen here, this process is used for the machining of electrically conductive materials only. The principle of working of ECM process is not new for us. It was basically discovered by Michael Faraday. It is called as electroplating. So if you see here, what is electroplating? Two electrodes, one is a anode, the other is a cathode. When two electrodes are dipped into a conductive liquid and a small DC voltage is applied across the electrodes, then the anode will start dissolving. The particles from anode one by one will start leaving the anode and they go and deposit on the cathode. This process is called as electroplating. ECM is nothing but a slight modification in electroplating process. You see the diagram here of electrochemical equipment. If you see here, the electrochemical equipment here, it consists of basically 4 elements. What are the 4 elements? The first element is the tool electrode, which is the cathode tool. Second is the anodic workpiece, which is the anode. Third is the electrolytic solution, which is fed in the gap between the tool and the workpiece. And the fourth is an electrolytic pump for pumping the electrolyte in the gap between the tool and the workpiece. These are the 4 elements. Now, to start with the process, the tool is connected to the negative, the workpiece is connected to the positive of the DC supply. Correct? And a small gap is maintained between the tool and the workpiece. There is a feeding mechanism for the tool to maintain the gap properly. The electrolytic pump is there for feeding the electrolyte in the gap between the tool and the workpiece. As soon as the DC supply is made on and the electrolytic pump is also started, which allows the electrolyte to flow in the gap. As soon as the supply is made on, the electrical reaction, the electrolysis reaction will start into the gap. And because of this reaction, the anode will start dissolving. As we saw in electroplating, the anodic dissolution takes place. And here, since the workpiece is the anode, the workpiece will start dissolving and these particles will come out, will leave the workpiece and they go into the gap. Then the electrolytic solution will flush away these particles from the gap. Otherwise, these particles may go and deposit on the tool. So before they deposit on the tool, they are flushed away by the electrolytic solution from the gap. So therefore, what is electrolytic solution? This electrolytic solution will allow the chemical reaction to take place, as well as it will flush the metal particles from the gap away from the gap and it will go out. These particles along with the electrolytic solution will come out and the pump will feed this electrolytic solution once again. There is a heat exchanger for exchanging the heat. There is a filter is there which filters the particles and the fresh electrolyte will once again be pumped into the tool electrode. In this manner, the electrochemical machining process is taking place. What actually the reaction is occurring here? What reaction is actually occurring in the tool and the workpiece gap? That is called as the chemistry of the workpiece. So what is the chemistry of the workpiece? You are able to see here the chemistry of the workpiece. Let us see what is the chemistry of the workpiece. It means the chemical reaction. What reactions are taking place in the gap between the tool and the workpiece? We all know that the tool, which is a cathode, is connected to the negative of the DC supply and the workpiece is connected to the positive of the DC supply. The workpiece is connected from the positive. Correct? Now, as soon as the DC supply is made on, the electrolytic pump will be started. It allows the electrolyte to flow in the gap between the tool and the workpiece. So as soon as the electrolyte flows in the gap, some reactions take place. Actually, what happens? See here, when the reaction will start, the water molecules absorb the electrons from the cathode. The water molecules absorb the electrons from the cathode and they free the hydrogen gas. They free hydrogen gas means they liberate hydrogen gas from the cathode, as well as they free the hydroxyl ions, OH minus minus. I will repeat once again. During the electrolysis of water, the molecules gain the electrons from the cathode and they produce hydrogen gas as well as hydroxyl ions. This is the first reaction that takes place. Then on the other side, workpiece which is a metal here, it is a anode. It is connected to the anode, positive of the DC supply. Second reaction will start here. So as soon as the reaction starts, we know that anodic dissolution takes place. Anodic dissolution means what? The workpiece metal particles will start liberating. The particles will dissolve. The particles will leave the metal. So the particles of the metal will come out one by one and they form metal ions. So M++. Workpiece will start dissolving. The shape produced on the workpiece depends upon the shape of the tool. So metal ions start forming. What is the third reaction? These metal ions combine with the hydroxyl ions and form metal hydroxides. These metal ions combine with the hydroxyl ions and form metal hydroxides. So the particles that we see in this gap, they are called as metal hydroxide particles. They are solid precipitates. Solid particles are there. These particles, if they are not flushed away by the electrolyte or by the electrolytic pump, they will go and deposit onto the cathode. That is why the electrolytic flow is maintained and its speed is at least 20 to 30 meters per second. And because of this speed, all the metal hydroxide particles are flushed away from the gap. They are flushed away from the gap and the new electrolyte is once again pumped into the gap. In this manner, the chemistry of the process is taking place. What is the next part? The next part are some important points about the ECM process. As we all know, the electrochemical machining process needs some important elements are there. It needs the tool electrode, different fixtures are there, electrolytic pump is there, and a DC supply is there. So that is why the initial investment of the equipment is high. The initial investment is high because of the tooling cost, the fixturing cost, and all the other costs. What is the advantage or what are the applications of ECM process? It is used for the machining of complex parts. It can machine all ductile materials, it can machine brittle materials, and it can machine any material which is difficult to machine by other processes. But the important disadvantage is that this process cannot be used for materials that are non-conductive. Keep in mind, very important point. This process is not used for the metals that are non-conductive. So non-conductive parts cannot be machined. The surface finish produced is very high. Material removal rates are also high. The one more disadvantage of this process is that sharp corners cannot be easily machined. Blind holes cannot be machined. Okay. Another disadvantage. Since the electrolytic solution is there are chances of corrosion of machine parts. This electrochemical machining process can be used for the machining of any cavities. It depends upon the shape of the tool. The cavity that you want to produce or the shape that you want to produce should be the shape of the tool. The tool should always be of the same shape of the cavity to be produced. Correct? So this ECM process can be used for grinding as well as honing. Grinding and honing. So if it is used for grinding, the tool will be a grinding wheel. It is called as electrochemical grinding process. The tool that we are using here, this will be a grinding wheel. It is called as electrochemical grinding. ECH means what? ECH means electrochemical honing. Honing is a surface finishing operation. Lapping, honing operations are there. So instead the tool is a honing tool. So when it is used for surface finishing, it is called as electrochemical honing process. I hope you have understood what is the principle of working of electrochemical machining process. You have understood what are the elements, what are the how the working of electrochemical machining process takes place. You have also understood the chemistry of the process. You have understood the advantages, disadvantages, the applications of the electrochemical machining process. Okay, thank you all.